Day 1, Episode 1 of Geometry Notes Online. I realized that I made videos and they wouldn't save, and now I'm remaking them and trying to upload them, and sorry about the lateness. We're going to do all this ahead of time. We'll be ready to go first thing Monday morning with the videos, and so it's more complicated than I thought. And so we're working on them. And so did you get your notes printed? If you're having trouble printing, make sure that you are under your Google account because there's permissions. But if you send me, I will grant. If your parents are logging in, it just takes me a little time. You might hear some beeps in the background while I'm doing this because some of you are emailing me right now and I can't get to them because I just got to finish this. And so the lone teacher has trouble talking to a screen with nobody around. So I got my seating chart right here. So that means I have you with me. And so I'll be calling on you in class just like we normally do. And so that will make it more enjoyable for me. So got your notes out? Here we go. And I can't really wear this. So I even dressed up, didn't wear a tie, but we're ready to go. So if you look at this, we're going to start a chapter on transformations. Transformations to transform. A transformation, take that word and write it right there. A transformation is any operation that moves a figure. And so transforms it. We take figures, like I have this stapler. I can translate it, that means slide. I can reflect it, that means flip. I can rotate it, that means turn. And I can dilate it just like your eyes and the pupil gets bigger. Wah! Right, like that. Jump, 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 jump. And so, why is that important in geometry? Because we've learned a ton this year. Look at this first picture up here. This picture, if I said, what is this shaded region? You could just take this piece right here, and you could move it right there. You could take this piece and move it right there. You could take this piece and move it right there. And all of a sudden, you know that you have a fourth of the picture. If I said, what fraction of square ABCD is this? You're like, well, that might be hard. But then if all you do is take it and turn it, then all of a sudden it's this, which is really bad drawing. All of a sudden you have half of the picture. And we have a fourth of the picture. And then we have a picture here, and it's like, this would be way too hard. Is this a trapezoid? Got parallel sides? How would I find the lengths of this? And how would I calculate the area of that shaded region? Well, then all of a sudden, if M and N are midpoints, I could take this shaded region, and I could move it right here. And all of a sudden, this represents a fourth of the whole picture. And by using transformations, and this would be a half turn right here, from this to go to this, you would just take it and half turn it 180 degrees, and it'd be right down there. And that we would get a fourth, and it'd become very simple. And so we're going to apply skills of transformations and do that. When you move an image, the new figure is called the image. Okay, mouse, you need to work. Get in line. And the original figure, that's image. That's I-M-A-G-E. And the original figure is called the pre-image. And I learned one thing doing notes today. I'm not writing words anymore. And we'll try to have most of it filled in for you because this takes too long with a mouse. So, we're going to learn some vocab words today. A mapping. This is M-A, come on, M-A-P-P-I-N-G, a mapping. It looks like a napping, but it's a mapping. It's a correspondence between sets of points, so that each point in the first set corresponds to exactly one and only one point in the second set. If you remember last year from algebra, we called this a function. Boom, and then we get that. So each one goes. A mapping and a function, those are synonyms when we are in geometry. A mapping function is called one-to-one, one-to-one. If when you reverse the mapping, it is still a function. And I forgot what goes in the next blank. Oh, that's pretty bad. And so a one-to-one mapping is a transformation. Same word. Right transformation right here. A transformation is a one-to-one mapping. Too much going through my mind right now. Sorry about that. A transformation maps every segment on this sentence, if a transformation maps every segment to a congruent, that's why in math we like symbols, a congruent segment, then it is called an isometry. Lots of words, they'll all make sense as we go through these days. And that's why we're going to get the homework started, and that's why we have the videos. And if you have a congruent mapping, that means all the distances, I never thought it'd take so long to write a word. All these distances are preserved, they're congruent. Now, certain mappings are isometries, like a translation. There's a distance here. If I slide this, it's the same distance on your screen. If I turn it, it's still the same distance. If I flip it, it's the same distance. But if I dilate it, woo, it got bigger. And that is not an isometry. And so this little picture, we used to have the function machine. Now we got the isometry machine. We warm it up. Boom, and it comes out. Well, this would not be an isometry. But what you look at this point A turned into point B. Well, what did it do? It took point X and turned it into 2x. And it takes the point. And so we don't write it like x to 2x anymore. We're going to write it like this. We're going to write xy, because it's an ordered pair, because it's a location graphing a shape. And we're going to tell you what it does to both the x and the y. So it's going to say, hey, multiply the x times 2. And then it's going to say, hey, multiply the y times 2. And then we will get a similar shape. And that one would not be an isometry. So what you're going to do on your homework is we have graphs pre-made for you. And here's some examples. And so we're going to plot some points. Hopefully I don't plot them backwards. Otherwise that would be embarrassing for the whole world to see. But we got the point 8. We call it 2, 0. We got the point B. That's 4, 6. We have point C. That's 6, 0. 1, 2, 3, 4, 5, 6. So there it is, right there. Now it says, those are called the pre-images. That's what we start with. Then it says to do what? It says for all your x's, add 2. Well, here are my x's. 2, 4, and 6. So add 2 of them. So maybe off to the side, I'm going to write my new ordered pairs so I know where I'm at. And so I had 2, 0. Well, now I'm going to add 2, and that becomes a 4. And my 0, what's 0? Plug it in right there. What's 0 minus 3? Well, that becomes negative 3. So then I plot that point. 4, negative 3. And that becomes my new A. So we call it A prime. Then we got a B. It was 4, 6. But now we're going to take the 4 and we're going to add 2. So it becomes a 6. We're going to take the 6 and, whoa, goes over here. And we're going to subtract 3. Almost missed that. And then that becomes 6, 3. So then B becomes 6, 3. And we call that B prime. B went to B prime. That's a B. C, we're going to plug 6 in. What happens to the 6? We're going to add 2. It becomes an 8. And then the 0, we're going to subtract 3. That becomes a negative 3. And so we have 8, negative 3. And that becomes C prime. Well, this makes a triangle. This is my image. The pre-image, the original image, is here. Is that an isometry? Yes, it's congruent. It's the same shape. It just slid it. And so what we're going to learn as we go through this, adding 2 is a slide to the right. Slide to the right. This one is a slide down. And there we go. Now, if it says find the pre-image of 9, 2, that means this is the new one. You got to go backwards. You got to go back. And so if we added 2 to go backwards, we're going to subtract 2 and get a 7. If we subtracted 3, we're going to add 3 and get a 5. So if it says in the book, find the pre-image, that means find the one that started it, not the one that ended it. Okay? And so let's do the next one. We have the original one, and I'm just going to plot it quick. Here's the original A, B, C. We got our little triangle. A, B, C. Easy as 1, 2, 3, do, re, mi, whatever that song is. So here we go. We got A, B, C. Now what is this going to do to it? We're going to take the 2 and we're going to plug it in. We're going to multiply by 2 and subtract 1. So we're going to write our new points. We're just going to plug them in. The x's go in here to the old points. The x's go here to the old points. The y's go here. And so we have 2 times 2, 4 minus 1 is 3. We plug 4 in, that becomes a 7. We plug 6 in, that becomes an 11. Now we plug the y values in of our pre-images. We plug 0 in, that becomes a 3. We plug 6 in, that becomes a 15. We plug 0 in, that becomes a 3. Now let's see what the new one looks like. 3, 3 looks here. That's A prime. What was that second one? 7? Ooh, this is bad. 7, 15. Oh, wonderful. Doesn't even fit on the graph. 7, 5, 10, 15. Guess this isn't going to be an isometry. It's not the same size. And then 11, 3. Right here. So what you did is, this new triangle, this monster one, up here, this is not an isometry. Because it's a dilation, it's changing sizes. And so you say, no to isometry. And you knew is because you're multiplying by 2. If you multiply something by 2, it's not going to stay the same size. If the virus multiplies by 2, more people get it. And so it's not going to stay the same size. Now, the pre-image here, you set this equal to 9. And you set this equal to 2. Set that equal to 2. And so you're going to get negative 1/2 for the third part. And then this, 2x minus 1 equals 9. Set this equal to 9. You'll get 10 and you'll get 5. So the second answer here is 5, negative 1/2. Okay? So down here, we got a couple more. X opposite of y. Our 3 points were right here. I'm just going to plot them. I'm not going to rewrite them all. And so 4, 6 was here. You can write them all on your paper. But here's your original triangle. Whoa, that's bad. And my hand shakes too much. There you go. So there's your terrible triangle. The x's don't move. They stay the same. But what happened to your y? It changed from positive 6 down here to negative 6. Zeros, the opposite of 0 is 0. It's its own opposite. And so the new triangle is right here. And it is an isometry. Multiplying by negative 1 does not change the length because you're multiplying by 1. So it's the same size. And if you had the image of 9, 2, that means the pre-image, what went to it, well, that would be 9, negative 2. Okay? Then for the last one, we have this point, what was it? 2, 0. Whoa! It's like going on a ride. And we got 6, 0. And we have 4, 6. The y values do not change. The x value, that used to be a 2, became a 5. So that's 5, 0. So this is my new A prime, which you should label because you don't have to write with a mouse. The 6, right here, plug it in over here, becomes a 1. And so then B prime is right here. And then my 4, if we plug that in, that becomes a 3. So 4 becomes a 3, but then it's 3, 6, and that's C prime. So what happened to this one is it is an isometry, but it like slid and flipped. Because normally we would write this as the opposite of x, negative 1x plus 7. So it means it slid to the right, 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 7, but then it went flip back, and that's where it's at. So it is an isometry, and if I want to know what the preimage of 9, 2 is, you just do negative 2, 9, and plug it in. Again, I'm scared to make these videos too long because it might crash the video. And so if you have any questions on your homework, you can let me know. On this worksheet, I forgot to type in a number 11. So you can put number 11 right here. And when you send it, take pictures of both sides. Some of you, when you sent your emails from the last assignment, you showed all the paths and you filled the beakers, but you did not show both ways to fill the beakers because I didn't give you space. So you could have done that on the back, but we'll take care of you no matter what. Just stay healthy, and we'll get back to you. Let me know if anything doesn't work. We'll get better at this. I can't believe I can't figure all this out, but we'll let you go. Okay, thank you. Na 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 na. Hey, goodbye.